Alright, Brandon Clayton here, the Algebra Guy, and as you can see on your screen, today's lesson, solving systems using substitution. So at this point, we've solved system using graphing, but there's a couple other ways we can solve systems as well. So let's start with substitution. This is connected to 5C, solve systems of two linear equations with two variables for mathematical and real world problems. So it's still the same as graphing, solving systems, but we're going to use a substitution this time. Alright, so solving systems of linear equations by graphing is a good way to visualize these two solutions. We talked about there's three types of solutions you can have. One solution where they cross at an intersection, another where there's parallel and there's no solution, another when there's infinite number of solutions because they're the same line. You can see that really easily on the graph. However, there are many cases when solving a system is just inconvenient and simply not precise. If the graph is going beyond that small grid, what are you going to do? You're going to try to extend the graph and connect those dots. Now you're getting into something that's questionable because you don't know how accurate it is. And if the solutions to the systems are not integers, it can be hard to read their values precisely from the graph. In this section, we're going to talk about using the substitution method so that you can have a workaround for those cases. All right, let's start by with this problem. So how do we use substitution to solve? Well, substitution, the idea is that we're going to substitute one answer and replace it with the other. So what do I mean? So for instance, we're going to take this equation here and let's solve for a variable and we're going to substitute it later. So the easiest variable to solve for here is y, because it's already by itself. It has a 1 in front. That's perfect. So I'm going to rewrite this 2x plus y equals 7, and I want to get y by itself by subtracting 2x on both sides, and that equals y. This is going to go to 0, so y equals negative 2x plus 7. So now that I know that this is the same thing as y equals negative 2x plus 7. So what does that mean? Now I can replace everywhere I see y here in the equation below with negative 2x plus 7, and that's what I'm going to do here. So let's change colors and show that. So instead of x minus 2y equals 6, I'm going to go x minus 2, and instead of y, we're going to put in negative 2x plus 7. Negative 2x plus 7. And finishing that equation is equals 6. So what do we do? Notice all we did was substituted negative 2x plus 7 in place of y, because we just found that y is equal to this. So they're the same thing. Now, what did that do for us as far as solving this equation? Well, what it did is it caused everything to have the same variable. Now I can actually solve it. Before I couldn't because it has two variables there, but now I can. So let's go ahead and do that. X and negative 2 times negative 2 is plus 4x. And we distribute here as well, negative 14 equals 6. Let's combine our like terms here to give us 5x minus 14 equals 6. Add 14 on both sides to get our x by itself. That gives us 5x equals 20. Divide by 5, divide by 5. X is equal to 4. Yay! Celebrate! So normally this was the point where we celebrate, and you could, but we're not finished. Why? Because remember, the solution to a system is the point where they cross. We have one coordinate. So far we needed an x and a y, but we only have an x, which is great that we have the x, but we still need the y. How can we find out what the y value is? Well, since we already know what the x value is, we can just plug that in to either one of these equations. Actually, we have three, this one, or this one, because all of them are the same thing, because these two are the same thing, and this one is the other of the system. Now, I'm going to plug it in to this one here because it just seems easier, because it's already solved for y, which is what I'm looking for. So I'm going to say equals y is equal to negative 2. Instead of x, we're going to put a 4 here, plus 7. Alright, so that means y is equal to negative 2 times 4 is negative 8 plus 7. Negative 8 plus 7 is going to equal a negative 1. So now I know my y is equal to negative 1. So there's my answer. Let me put it here so it's easy to see. We got 4, -1. Now, if you're not sure, you could actually plug it into the other equation to see if it works as well. So we just found that it's true for this equation, for these two, because these are both the same thing. But what if it should be true for this one as well? So let's plug in x and y here and see if we indeed get 6, and if they're equal. So in place of x, I'm going to put 4 minus 2 times my y, which is -1, equals 6. So this should give me 6. -2 and -1 gives me a positive, so that's 4 plus 2 equals 6, and we see already that these are indeed the same thing. So that's how you solve with substitution. Let me recap. All I did was took one of the equations and solved for a variable. In this case it was y because it was easier. Now you could have used x as well, but why not take the easier route? And when we found that -2x plus 7, we simply substituted it into the other equation everywhere where we saw y. And when we did that, we were able to solve for x. And once we found x, we plugged it back into the equation to get y. All right, if one of the equations in the system is in slope-intercept, it's already done for you. So one of the steps are already done because they've solved y for one of them. So I'll start with that one. So I already know that y equals x plus 5. So in place of this y, guess what I'm going to put? Yep, x plus 5. So x plus, now in place of this y, I'm going to put x plus 5. X plus 5. And I'm going to continue writing that equation equals -1. So what did I do? I simply replaced y in place for x plus 5 because they're exactly the same thing. Now let's solve for this one. This is x plus x, which is 2x plus 5 equals -1. Subtracting 5 to get my x by itself gives me 2x equals -6 divided by 2, and x is going to equal -3. So I have my x value. Yay! Now I need my y. So what's the y value? Easy to find, right? Just use one of these equations and plug -3 in there for x. I'm going to use this one here. So this becomes y equals, in place of x, I'm going to put a -3 plus 5. Well, -3 plus 5 is a +2. +2. So now I know that's my point. Now I could check it again. It's -3 and 2 should work for this top equation as well. Let's see. So in place of x, I'm going to put -3, and that's plus y. My y value is 2 equals -1. Is this true? So yes, these are both equal. So now I know for sure that this is the solution to this system. Now I've done that by substitution. All right, if the equations are given in standard form, we're going to need to start by solving for one of the variables. Now it doesn't matter again which one you solve for, but let's try to choose the easiest one. The easiest one is going to be the one with a 1 in front of it because it already has a 1, which is what we're looking for. So in this case, again, it's y. Again, it could have been x, but it was y. I can see right here. Now you could choose 3x, 2x, 4y to solve for, but I wouldn't make it harder than you have to. I'm going to use 3x plus y equals 5 and solve for y. Pause it here and see if you can work it before I do and come up with the solution to this system. All right, I'm going to continue with this at -3x and y equals -3x plus 5. So now I know that this is the same thing as y equals -3x plus 5. Why is that important? Because now I can plug in, instead of y here, I can now plug in -3x plus 5. So that's what I'm going to do. So I'm going to put 2x plus 4, but this time instead of putting y, I'm going to put -3x plus 5 because it's the same thing as y. So times -3x plus 5 equals -10. All right, now I can have everything in one variable. I can solve for x. So this becomes 2x plus, or actually 4 times -3 is a -12x, and plus 20 equals -10. combining my like terms, 2 and negative 12, I get negative 10x plus 20 equals negative 10. And I want to get my, let me do it this way. I want to get my x by itself, so I'll subtract 20. So that becomes negative 10x equals negative 30 divided by negative 10, negative 10. X is equal to 3. Now, I circled that, but I'm cautious. I shouldn't have circled it, actually. I'm going to undo that because it makes you feel like we're done. But we have now the x value of 3, but I'm still looking for my y. So now I know that x is 3. I can plug 3 back into either one of the equations to find y. And as you can imagine, I'm going to use this one here, negative 3x plus 5. But I'm going to use it over here, negative 3. Instead of x, I'm going to put 3 and then plus 5. Negative 3 times 3 is negative 9 plus 5. And that's going to equal a negative 4. Negative 4. Solving by substitution. So you can check your answer again by plugging 3, negative 4 into the bottom equation to see if it's true. But I'm pretty sure it is, so we're going to stick with that. All right, in the last example, it was easy to solve for y in the first equation because they had a coefficient of 1. However, in this example, it's going to be easier to solve for x. So notice that x is the one that's easier to solve for, so that's which one I'm going to choose. So I'm going to do x minus 2y equals negative 2. And this time I want to get x by itself by adding 2y on both sides. And that's x equals 2y. And what do we have? 2y minus 2. There we go. There's my minus 2. So now I know everywhere I see x in this other equation, I can replace it with what? 2y minus 2. Good. So now I'm going to rewrite this equation. 3 times x. So instead of x, we're going to write 2y minus 2. And we're going to continue that equation with plus 2y equals 34. Distributing here to solve for y, I get 6y minus 6 plus 2y equals 34. Combine my like terms, 6y and 2y, I get 8y minus 6 equals 34. Add 6. And that gives me 8y equals 40. Divide by 8 on both sides. And we get y equals 5. And I circled it again, but I don't want to make you think that that is our final answer. So we need to find our x. So how do we find our x? We're going to plug this 5 back into either one of these equations. It's easier to put in here because look, it's already solved for x. So I know that x is going to equal 2 times my 5 minus 2. Well, x is equal to 10 minus 2. So that means x is equal to 8. And there's my solution to that system using substitution. All right, when both equations are already solved, it's even easier. Look, y equals and y equals. That means they're the exact same thing. Y is equal to this and y is equal to that. They're telling you that they're both equal. So I can actually literally set them equal to each other. So I can rewrite this to say negative 2x plus 5 is equal to 1/2 x. Why? Because y and they're both y's. This is equal to this. Now I can solve for this equation. Let's see the best way. I like to get rid of my fractions oftentimes as a first step. So I'm going to multiply both sides by 2 to do that. So over here is where I was concerned. I just want to get rid of this fraction to make it x. 1/2 times 2 is x. Negative 2 times negative, 2 times negative 2 is negative 4x. And distributing here gives me a 10. Getting my x by itself, I can add 4x on both sides. Or not getting it by itself, but getting it on one side. That gives me 5x. Divide by 5. And that gives me x equals 2. All right, so we're not done, of course. So I got to be careful with that circling because I want x and y. So I have my, let's put it here, my x value of 2, but I want my y. To find my y, I just plug in 2 in place of x here on the bottom or here on the top. It doesn't matter. This looks even easier, so I just plug 2 here. What's 1/2 times 2? Well, you might be able to get that in your head, but I'll write it out just to be sure we see it. 1/2 times 2, y is going to equal 1. Because you got 2 halves, half and half is going to make a whole. There is your solution to that system. All right, be careful with the signs in this one because you see this y by itself, but it has a negative sign next to it. Sometimes students may forget that or just dismiss it altogether, but we don't want to do that. So I'm going to solve for a variable here, and I'm going to pick this y because it already has a 1, or rather a -1, and it shouldn't be too difficult to get by itself. So 6x minus y equals 8. I'm going to subtract 6x on both sides. And I'm left with -y equals -6x plus 8. So notice here that I still have a negative. So that's a -1, which is a number we need to not have right there. We need a +1. So in order to get rid of that, you can multiply or divide by -1. It's going to give you the same answer. I'm going to multiply by -1 on both sides. Because negative times a negative now is going to make this a positive. And this -1 distributed to both of these is going to make this a positive 6x and a -8. So now I can replace this positive y with 6x minus 8. So we're going to put, instead of 4x plus 2y, instead of this y, we now can plug in 6x minus 8. 6x minus 8 equals 4. I'm distributing here. 4x is going to give me 12x minus 16 equals 4. Combine my like terms. Equals 4. Add 16 on both sides. And we get 16x equals 20. All right, from here we're going to divide by 16 on both sides. That gives me x, as this cancels out here, and 20 over 16. I notice that can be reduced by dividing by 4 on both the top and bottom. So that's the same thing as 5 over 4. Ew, we got a fraction. But that's actually the benefit of using substitution, because how difficult would it have been to see on a graph that x is 5/4, or in other words 1 1/4, or 1.25. It's tough to see that. So this is actually the purpose of substitution, is to make sure that we get an answer even if it's not an integer. So we have an x value of 5/4. So what's the y going to be? So let's plug it back into this equation to find out. So we got 6. Instead of x, we can plug it back in to get 5/4 here. 5/4 minus 8. So that should give us our y. This is 30 over 4. This equals 30 over 4. Or 6 over 4 is the same thing. I better do it this way. 6 times 5 is 30. And over 4. That way you can understand what I'm doing. Because I was going to say 6 over 4 and simplify that, which you can do it that way, but I want to make sure you're with me. All right, so I can simplify this now. They both can divide by 2. 15 over 2 minus 8. So what is 15 over 2 minus 8? So let's do 15 over 2. 15 over 2 minus 8. I need a like denominator. This has a 1, so let's change this denominator to a 2. So that'll be 15 over 2. 2 times the top is going to be 16, and 2 on the bottom. So 15 minus 16 is going to give me a -1/2. So y is going to equal a -1/2. -1/2. All right, some of our problems require a little bit more work. In this problem, you don't see one that's easily quickly to solve. I mean, you have a 4, 3, 15, 20. None of them have a 1. So you're just going to have to put a little bit more work in for this one. So let's pick one that seems easier. I'm going to choose the 3. I guess it's the smallest, so let's choose that. It doesn't matter which one, but I'll go with that one. All right, so let's get 4x minus 3y equals 6. So we're going to solve for y. So I'm going to subtract 4x. Subtract 4x. That leaves me with negative 3y equals negative 4x plus 6. Divide by negative 3. Divide by negative 3. These canceled out to give me y is equal to a 4/3 x. 4. I'll make that better. 4/3 x. 6 divided by negative 3 is a negative 2. So this is what my y equals. Ew, that doesn't look fun to deal with, but that's what it is. So we'll just work with that. All right, so we found that this is the same thing as y equals 4 equals 4/3 x minus 2. So we can plug in 4/3 x minus 2 everywhere we find a y. So let's do that for the second equation. 15 times, instead of y, we're going to put 4/3 x minus 2 and minus 20x equals negative 30. All I did was continue writing that equation. So let's solve this one. Notice we got everything in terms of x, so we can actually solve it now. 15 times 4/3, well, 15 divided by 3 is 5. 5 times 4 is 20, so that's going to give me 20x. I just did distributing there. 15 times negative 2 is negative 30. And negative 20x equals negative 30. Combining my like terms, I got 20x and a negative 20x. So those are going to go away to just negative 30 equals negative 30. So interesting. So what's going on here? What's happening is that these two are exactly the same equation. So this is one of the instances where the solution is infinite. Like you have infinite number of solutions because these two equations are exactly the same. Matter of fact, I asked that question here. Looking back at this last question, was there any way we could have recognized that these were the same lines? So if you actually look carefully, if you look at this second equation, 15, 20, and 30, we could have factored out a common factor they all have in common. So we could have taken out a So we could have taken out a 5 out of each one of these. So let's do that. If I would have divided 5 out of 15, that would have given me a 3y. Divided 5 out of negative 20, that would give me a negative 4x. And divided 5 out of negative 30, that would give me a negative 6. So notice that it's starting to look a little bit like this problem. Matter of fact, if I rearranged these so that the x is first, I get negative 4x plus 3y equals negative 6. So I didn't change anything here. I just moved them around. They kept the same power. But it's almost like this one. Only thing is different if I would have multiplied both sides by negative 1. And now that would change this to so negative 1 and negative 1. So that this now becomes a positive 4x, a negative 3y, and a positive 6. And look at what we have. The same exact equation. So if you start to see big numbers like that, the first thing I try to do is see if I can factor it out. And they tend to be the exact same equations. So this has infinite number of solutions. So there's not just one point they're equal. They're equal at every single point. So let's go to our next problem. All right, let's solve this system. Should be easy. Well, they already gave us y equals. So we're going to just plug that 5 over 2x in place of my y here. So let's rewrite that as 5x minus 2. So in place of this y, we're going to put 5/2 x. So 5/2 x, or 5 over 2x. That's going to equal negative 10 as we continue writing that equation out. And let's solve for it. 5x. 2 divided by 2 is just going to give us 1. We still got this negative, so that's going to be a negative 5. X equals negative 10. So 5x minus 5x equals 0. Nothing there, and that equals negative 10. What's going on here? In this case, we have two lines that are parallel, and they're never going to cross. See, when they were exactly equal to each other, we knew they were crossing at every single point. But these two are parallel. Well, how did you know? Because if we would have solved this one for y, which I'm going to do now to show this to you, So let's rewrite this. So let's solve for y here by subtracting 5x. That's negative 2y equals negative 5x minus 10 divided by negative 2. That equals y, because these cancel. Negative 5 divided by negative 2 is a positive 5 over 2x. And negative 10 and negative 2, when you divide them, give me a positive 5. So look, I have the exact same slope. So this is the same as this equation here. I notice that I have the exact same slope, 5/2. So that means they're parallel. And this one has a y-intercept at 0, while this one has a y-intercept at 5. So if I were to graph this to give you an idea, we have one that's moving up like this, right here in the blue, and we have another that's on the y-intercept at 5, but has the exact same slope. And so this one, the answer to this one has to be what? No solutions. It's never going to cross because they're parallel with different y-intercepts. They're never going to intersect. And that completes it. Solving systems of two linear equations with two variables using the substitution method. So that is it. We've done graphing. We've done substitution. Next will be elimination. Thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.